Hey everyone, welcome to 3-1, factoring ax² plus bx plus c. As you can see, this stuff we've already done. So if you go back to like the factor and FOIL videos, really like videos 2, 3, and 4, we really got into factoring. And so when we went through this, it was pretty easy. They picked it up and went, oh yeah, that's right, I remember that. So first thing we did is we talked about greatest common factor. It's very possible for all three of my terms to have something in common, whether it's a number or a variable. If that's the case, that's what we want to pull out. Like, remember greatest common factoring, if you go back to those videos, it talked about it being like backwards distributing. And if you notice, like, here's my answer, but if I distribute this 5 to everything, I get back to where I was. If I distribute this y to everything, that's where I get back to where I was. So we just looked at these, and they were pretty easy to figure out, like, oh, I could pull a 3 from all of those. I can't pull a 9 because I'll have a fraction here, but I can pull a 3. So those were fairly easy, just remembering how to get a greatest common factor. Then we started here. 5x² plus 15x plus 10. Well, since we just talked about greatest common factor, they were like, oh, well, let's pull out a 5. Fantastic, and we got here, and they thought maybe we were done. Well, most of these now can then be factored this way if you remember how to do it. A times c, because here's ax² plus bx plus c. When we take out a 5, we have a new a, b, and c. So a times c on top, b on bottom. These two numbers got to multiply to the top and add or subtract to the bottom. If my a value is 1, throw the x's in front. Don't forget this 5 down here. Again, some of this was in the factor and FOIL video from before. No greatest common factor. So a times c on top and b on bottom. 12 times 1 is 12. 12 plus 1 is 13. But this is when we took 4x and put it over 12 and put it over 1 and simplified. This simplified to 1/3, so we wrote it as x plus 3. And 4x plus 1 is technically 1, or technically 4. But we need this like positive 1 down here, so we can read it as 4x plus 1. Without the without that, if we reduce this to 4, then this 4x would just kind of distribute, and we'd get the 4x², but then we get 7x and nothing else. So to get the rest of it, that's why that has to be there. This 1 on bottom still has to be there. Here's another example we went through pretty quick. 6 on top, -7 on bottom, so both of my signs were negative. Same signs, add and keep to the bottom. 3x over -6 reduced, 3x over -1. Really needed to stay just like that. Same thing here, except I have a negative on top, which means different signs. I can only get to a negative by a positive times negative. So then it's up to us to figure out, did I want 7 minus 2 or 2 minus 7? Well, to get to -5, I needed 2 minus 7. And of course, we do our little fraction thing, reduce. That becomes x plus 1. Like I said, I'm kind of going through fast. Here's something a little bit different, though. You could technically set this up. -20 on top, but it would give you a -8 on bottom. These would switch, this would all switch, and it gets weird because a lot of times you think, oh, well, I have negative, like basically all your signs are different. So what we do instead, I don't like having that negative there. Pull out the -1, change that sign, change that sign, do this as normal, and then just throw the -1 back in. Because otherwise, like, it really messes with the answer, and it's not quite right, because you usually get like a negative here and a negative here, and then negative times negative is not the negative we're looking for. So we pull out the negative first. That way we know we have positive times positive equals positive, and that negative comes back later. Here's the homework for it, for my class. But yeah, that was about it. Again, just go back to the factor and FOIL videos, 2, 3, and 4, if you need a little extra help. But